Welcome to Let's Get to the Marks, looking at crude oil and fractional distillation. So crude oil, yep, you can see from this video here, that's what powers our cities, cars, aeroplanes, lorries, boats, ships, power stations, everything basically. Seriously important substance. Mainly made from the marine organism known as plankton. That's the stuff that whales feed on. Now, hundreds of millions of years ago, when plants and animals died, a very small percentage of those plants and animals would die and decay in quite extraordinary conditions, which would lead to the formation of crude oil. Now, what do you need to know for your exams? Well, if we're just getting to the marks, you need to know that crude oil is formed over hundreds of millions of years, or a long, long time. It comes from the dead remains, or the remains of dead organisms. You can name plankton, but really any animals and plants, and that it requires heat and pressure. That's the heat from the Earth's core and the pressure from layers of rock over millions of years pushing down on these remains of dead animals. But really, we're talking heat, pressure, millions of years, dead plants and animals or organisms. Okay, crude oil is a fossil fuel because of the reasons we've just talked about, being made from the remains of dead organisms. It's also known as black gold. You don't need to know that, but crude oil is an incredibly valuable industry, one of the most valuable industries in the world. I think it's worth something like 5 trillion. Yeah, here's some animals and plants that could decay and one day become crude oil. Yeah, great. Let's look, what do you do with crude oil? Well, crude oil is pretty useless as a substance on its own. It's thick, it's black, it's a mixture of lots of useful substances put together, but it's too thick, not very flammable to be used as a fuel, and not very useful in its raw form that it's drilled out of the ground. So what do we need to do? We need to separate crude oil into all those useful components, fractions we call them, all the separate parts that make up the mixture that is crude oil. So how do we do this? We do this by fractional distillation. What do you need to know? Well, first, these columns, by the way, these fractional distillation columns or towers are really big. They're 40, 50, 60 meters tall, very, very tall. So they process a lot of crude oil. Okay, we're going to separate this, and this can be a 5-mark or a 6-mark question. How do we, or 4-mark question, how is crude oil separated? They may name a specific component and say, how is this separated? But they basically want you to state out the process of separation. So let's go through it. Step 1, crude oil enters the column. It is vaporized. They do normally allow heated on the mark scheme, or evaporated or boiled, but you definitely will get the mark on vaporized. So there is a temperature gradient. You might not remember that fancy term, but it means that the tower is hot at the bottom and cold at the top. And you can just say that. You can just say the tower is hot at the bottom and cold at the top. Longer hydrocarbons have higher boiling points and they condense lower down. So they come out first. We've got bitumen coming out of the bottom. That doesn't actually vaporize. That's the liquid stuff that doesn't vaporize. It's not hot enough to vaporize the bitumen. But the rest of the components or fractions within the crude oil, or hydrocarbons, you can call them, they vaporize and rise up the tower. First one out, heavy fuel oil, 40 carbons long. That's quite a long carbon chain. That's the first one to condense and come out. Second one out is diesel, used in cars, but mainly lorries. Second one out. Third one out, kerosene. That's used for aeroplane fuel, 15 carbons long. That condenses next. It has a lower boiling point than diesel or heavy fuel, which have a higher boiling point. Okay. Shorter hydrocarbons, smaller ones like methane, ethane, propane, butane, pentane, hexane. These shorter hydrocarbons have weaker intermolecular forces, so they have lower boiling points and they come out higher up the tower. So petrol, which is mainly made of 8 carbons, which is octane, and LPG, which is like natural gases like methane, ethane, propane, and butane. The ones you have to know the displayed formula for, they come out at the top. They're actually gases at room temperature. Things like the gas that comes out in your Bunsen burner or your cooker at home or your heating system for heating your home, those come out at the top there. Okay, what are the uses of these different fractions? So bitumen, which doesn't actually vaporize, it just comes straight out as a liquid from the tower. Bitumen is used for road surfacing. So you've probably seen when builders or people are working on the road, laying a new road, this thick black substance, that's bitumen. It's also put on garage roofs and shed roofs as well to waterproof them. Heavy fuel oil is used in power stations, so we get a lot of our electricity from burning fuel oil, and it's used in big ships, container ships that transport cars and other cargo around the world. Diesel is used for fuels in trucks and lorries. Kerosene is for aeroplanes, and petrol, the most valuable one to have in your crude oil, is used as car fuel. And finally, at the top, we've got gas. So gas in lighters, your cigarette lighters, your camping gas, barbecues, heaters, those kind of gases, they're coming out at the top. That LPG can also be called natural gas. Okay, so looking at, here's a picture, a photograph of real fractional distillation towers. You can see they've got stairs going up, platforms going up, where workers can go up and down the tower and make sure everything's working correctly. Something that you have to know that comes up as a very common question is you have to be able to compare the color, the flammability, the volatility, and the thickness of different fractions. So they may ask you, compare petrol to kerosene or compare LPG to heavy fuel oil. And what you've got to compare them in is color. So we would say smaller hydrocarbons. If we look at LPG, it would be lighter in color than bitumen. It will be more flammable than bitumen. Higher in volatility means it evaporates easier. It has a lower boiling point than bitumen. And less viscous, viscous is a fancy name for thick. So less viscous means it's more runny or less thick. And you have to be able to describe that. So practice being able to describe that. It's a very common question. So if we compare petrol and heavy fuel oil, yeah, petrol's lighter, more flammable, easier to burn. So you could say it's a better fuel. Higher volatility, and it's more runny than heavy fuel oil. Okay, we've got some questions here to go through. Let's go through these fractional distillation questions. So you might want to pause the video and have a go at these questions, and then we'll go through the answers. So the diagram shows the separation of crude oil into fractions. You've got the crude oil vaporized and coming in the bottom. What is the name of this whole process? Well, it's fractional distillation. He says, oh, there, it's appeared. Complete the table by giving the correct fraction A, B, C, D, E, or F for each description. You may use the letter once, more than once, or not at all. So, which fraction only contains gases? Which of these, A, B, C, D, E, and F, is only gases? Well, that will be the ones at the top. Methane, ethane, propane, and butane with only 1 to 4 carbons. They are gases at room temperature, so they're going to come out as gases. Which one is the most viscous, the thickest? Well, that's going to be right at the bottom, the one with the most carbon atoms. So that is bitumen, which is F. And then which one contains bitumen? Well, that's F again. So a little trick there that they like to do. Let's look at the next question. You could pause the video and have a go. I'm going to go through the answers. So pause it if you want to have a go at the questions. Okay, let's get into it. The diagram shows a typical fractionating column used to separate crude oil into fractions. The diagram shows the names of some fractions. State the name of fraction A and the name of fraction F. Well, we just looked at that. So fraction A is LPG, or natural gas, and fraction F, right at the bottom, is bitumen. Right, describe how the boiling point, color, viscosity, that's the thickness, of the fuel oil fraction differs from gasoline. So they've asked us, they've mentioned fuel oil first, so they want us to talk about fuel oil compared to gasoline. So fuel oil is a bigger molecule. It's going to have a higher boiling point. What about its color? Well, its color will be darker. And what about the thickness? Well, the viscosity will be higher, or it will be less runny. So higher boiling point, darker, thicker, more viscous, or less runny. Okay, and finally, one that combines basically that it says, how do we separate crude oil? So you're going to get marks for saying, oh, by fractional distillation. That's a key term. So just saying in a fractionating tower or fractionating column, just if they haven't mentioned fractional distillation or fractionating tower in the question, it's definitely on the mark scheme. So you can just say using a fractionating tower, using fractional distillation. What happens to the crude oil when it comes in? What was the first thing we do to that crude oil? We vaporize it and turn it into a gas, and it rises up the tower. So then it rises up. That could also be a mark. What happens next? The tower, what's the temperature like? Can you remember the temperature? It's hotter at the bottom, colder at the top. That's another mark. Or you can say it has a temperature gradient. Then the fractions are different sizes. Some molecules are big, some molecules are small. They have different boiling points because of this. Big ones have higher boiling points. Smaller molecules have lower boiling points. Which ones go further up the tower? The smaller molecules go further up. That's another mark. Bigger molecules come off at the bottom. What's the key word for when a gas turns back to a liquid? The word is condense. So that's definitely on the mark scheme. If I say big molecules condense lower in the tower, or smaller molecules condense higher up the tower. You can even just say, if you can't work it out in your head, do the small ones come off or the big one? What's going on? You can just say different fractions condense at different heights of the tower, depending on their boiling point. So as long as you know it's something to do with boiling point and something to do with where they condense. Condense is a mark, different boiling points is a mark. So loads and loads of information there. Let's look at the mark scheme. So you get a mark for saying they're heated, evaporated, vaporized, boiled. You get a mark for saying the temperature is hotter at the bottom, cooler at the top. You get a mark for saying just the word condense, and then at different levels. So if you try to explain smaller ones condense at the top, bigger ones at the bottom, you would get all the marks. And they've got the allows as well. So I hope that was helpful, guys.